Okay, today we are going to start Chapter 6. Chapter 6 is on different kinds of transformations. Essentially what that is when you take a geometric figure and you change it in some way. So a transformation here, it says, is an operation that maps an original geometric figure or the preimage. So the preimage is what we call the original, onto a new figure, which is called the image. So preimage is where we started, image is where we finish. Specifically today we're going to talk about a translation, and that slides a figure from one position to another without turning it. Okay, so there's no turning, we just slide it. Okay, down here feel free to fill in the word map to help you understand translation better. Define it in your own words. It's sliding the figure. 3 characteristics: they don't turn. Okay, an example would be right here. That's a poor drawing, but we just slid the triangle over there. A non-example would be something like this, okay, where you obviously turned the figure. All right, moving on. Key concept: translations on the coordinate plane. So one thing we need to keep in mind is on the coordinate plane, if we are moving left and right, that is controlled by the x-axis and thus the x-coordinate. And if we're moving up and down, that is controlled by the y-axis and the y-coordinate. So if we want to move so many units to the right, okay, we would add to the x-coordinate. If we want to move to the left, we would subtract. If we want to move up, we would add to the y-coordinate. If we want to move down, we would subtract from the y-coordinate. So when translating a figure, every point of the preimage is moved the same distance and the same direction. Okay, so the preimage is where we start. The image and the preimage are congruent, which means and congruent means figures that have the same shape and same size. They're equal. So line segments in the preimage have the same length as line segments in the image. Angles in the preimage have the same measure as angles in the image. Okay. So your angle measures stay the same. They're not going to change. Our figures are completely congruent, which means they are equal. Another side note over here, if you take a look, it says, see if I can zoom in on that. It says we use prime symbols for vertices in a transformed image. So if I have A, B, and this should be C, okay, if I see a little apostrophe, that means A prime, B prime, C prime. And we do that so we know what we're dealing with. Okay, so we know these are all in the preimage and these are all in the image. Okay, so we know that that vertice lined up with that vertex from the preimage to the image. So let's take an example here. So we want to graph triangle JKL with the vertices given, and then graph the image of JKL after translation 2 units right and 5 units down, and then we're going to write the coordinates of the vertices. So to start, JKL, -3 and 4. That's J. K is 1, 3. And L is -4, 1. So then I can connect the dots here. And this would be the graph of my preimage, or my starting position. So now I need to translate 2 units to the right and 5 units down. Probably the easiest way to do this is count 2 units to the right and 5 units down. So if I start with K, 2 to the right, 1, 2, 5 down, 1, 2, 3, 4, 5. Okay, so that was K in the preimage. In the image, it'll be K prime. So I go to J, 2 to the right, 1, 2, 5 down, 1, 2, 3, 4, 5. J prime. L, 2 to the right, 2 down, or 5 down, 1, 2, 3, 4, 5. This would be L prime. So as you can see, the only difference between triangle JKL and triangle J prime, K prime, L prime is its position. Otherwise, they are congruent. Okay, I've taken the whole thing and I've moved it over 2 and down 5. Go ahead and pause the video and try A on your own, please. Try A on your own. I'll be back in a minute to go through that with you. So we should be back from pausing the video and trying A. First we graph it. 4, comma, negative 3. 1, 2, 3, 4. 1, 2, 3. That is A. B is 0, comma, 2. And C is 5, 1. So that's A, B, C. Connect my dots. And there you have the first one. Now it says graph its image after a translation of 4 units to the left and 3 units up. So 4 to the left and 3 up. 1, 2, 3, 4, 5. 1, 2, 3, 4. And 3 up. 1, 2, 3. That would be B prime. C prime, 4 to the left. 1, 2, 3, 4. 3 units up. 1, 2, 3. And A prime, 4 to the left, 1, 2, 3, 4, and 3 up, 1, 2, 3, A prime. And now what you'll see here is our image is going to kind of cut off part of our pre-image, but that's okay. So here you can see we took the same triangle and we just shifted it up to the right. Now one thing I forgot to do on the last one that we're going to do on this one is write the coordinates of the image. So the image is A prime, B prime, C prime. So all I need is the coordinates x comma y for A prime, which is 0 comma 0. B prime would be negative 1, 2, 3, 4, negative 1, 2, 3, 4, comma 1, 2, 3, 4, 5. And C prime would be 1, comma 4. So don't forget to do that. I know I forgot to do that on the example, but you should be going through the entire video, so you should have got this one. Okay, example number 2. Now, we don't have a graph. It says triangle XYZ has vertices of X, Y, and Z. Find the vertices of triangle X prime, Y prime, Z prime after translating it 2 units left and 1 unit up. So here's the way we do this. We want to list our points out. X, negative 1, comma, negative 2. Y is 6, comma, negative 3. And Z is 2, comma, negative 5. Okay. What I like to do is write out my translation here in the middle. Okay. So here I have the points X, comma, Y. My translation in the middle. Okay. Now if I'm moving 2 units to the left, the x-axis and the x-coordinate control the left and right. Okay, so if I'm moving to the left, that's going to subtract 2. So I take x minus 2. And 1 unit up. So up and down is controlled by the y. So if I'm moving up, that's in a positive direction on the y-axis. So I'm going to take y plus 1. So that's going to be my translation. So when I do that, I get x prime. Now, I take my x-coordinate here, which is negative 1, and I subtract 2 from it, and I get negative 3. Here I have negative 2, which is my y-coordinate, and I add 1 to it, and I get negative 1. So that's my new point. Y, my x-coordinate is 6. I subtract 2 from it, so my new x-coordinate is 4. My y-coordinate is negative 3. I add 1 to it, so my new y-coordinate is negative 2. And the same for z. Z prime, my x-coordinate was 2. I subtract 2, so my new coordinate is 0. And negative 5 was my y-coordinate. I add 1 and I get negative 4. Now, if I wanted to graph these, this would be my pre-image. This would be my image. Where I started where I ended. I really like writing it out like this because it clearly shows what I did in my translation. Okay. All right. Once you guys try B, try that one on your own. I'll be back in a minute to go through it with you. Okay, we should be back from trying B on our own. So let's go through it. Start by listing our vertices. A, B, C, D. And now our translation at the top. So I had x comma y for my coordinates of my point. And now if I'm moving 4 units to the right, okay, 4 units to the right, that's controlled by the x-axis. And since I'm moving in the right, that's a positive direction on the x-axis. So I'm going to add 4 to my x-coordinate. Now 2 units down, up and down is controlled by the y. So if I'm moving down, that's a negative direction on the y. So I'm going to take y minus 2. Okay, and that's going to be my translation. That's going to be my guide to help me find these points throughout the problem here. So now A is going to turn to the point A prime. So I was at 0 for my x. I add 4 to it, and I get 4. I was at 0 for the y. I subtract 2, and I get negative 2. For B prime, I was at 2. I add 4, and I get 6. I was at 0. I subtract 2, and I get negative 2. C prime, I was at 3, I add 4, I get 7. I was at 4, I subtract 2, I get 2. And D prime, I was at 0, I add 4, and I get 4. I was at 4 for the y, I subtract 2, and I get 2. So now these would be the vertices for the quadrilateral A prime, B prime, C prime, D prime. Okay, again, where we start is called the pre-image. Where we end is the image. All right. Now let's take a look at one more example. This time we're going to work on finding the translation. So now instead of them giving us the translation, we're going to find the translation. So a computer image is being translated to create the illusion of movement. Okay, this is the fundamentals of animation here, folks. By frame, you change the position, you speed up the rate at which you show the frames, and that's how you animate things. That's how you give the appearance of movement. Okay, now this compared to your video games and your animated TV shows and movies, this is basic level stuff, but it is the same concept that is applied to those fields. So let's see, we're translating a computer image. It says use translation notation to describe the translation from point A to point B. Translation notation, that's everything we've been doing already with x comma y and an arrow and turning it to whatever we do to the x and y coordinate. Okay, that's what we've been doing on the last example. So if I started at A here at 3 comma 3, I went, first of all, what did I do to the x-coordinate? The x-coordinate controls the right or left. So from here, I went back 1. Okay, so that would be x minus 1. And now from y, think about this, if I just go back 1 here, on the y, I went down 2 to get to that point. Okay, so if I go down on the y, that's a minus 2. So this would be written in translation notation, and this would be my answer for that translation. Okay, remember, x-axis controls the left to right, y-axis controls the up and down. All right, that's it for the lesson. Here is the assignment. Let's see if you can read that yellow. It's 1 through 9, odd, 13 and 16. 13 and 16 should be on eBackpack. But go ahead and get started. Choose the assignment that is right for you. And as always, have a great day.